So we're talking about first sets. We have a question about first sets. So why don't you describe to me the grammar that you want?
Yeah, so the context-free grammar is going to be S goes to, these are all non-terminals, non-terminals, A, B, C, D.
Cool.
The next rule is A goes to C, D, or little a, big A.
Okay.
The next rule is B goes to little b.
Okay.
The next rule is C goes to little c, big C, or epsilon. And then the final rule is D goes to little d, big D, or epsilon.
Cool. So it's the first thing we do.
First thing we're going to do is initialize every first to the empty set, right? So we
What's
take
first?
the non-terminals in the grammar.
All right. So our goal, right? We always want to think whenever we're going to do something, what's our goal? What do we want, right? So here, depending on what the question asks you, we want the first of S, the first of A, the first of B, first of C, first of D. So
Okay.
First of S, first of A, first of B, first of C, first of D. And as you said, we initialize all of these to the empty set.
Right.
Now what?
Okay. Now what, indeed? So we start with first of S, right? Like we try to compute that.
We can start anywhere we want. Let's say.
Okay.
So we want to apply all our rules to calculate a new value for first of S.
Okay. So
So which rules do we look at?
the first rule,
The first rule.
Yeah.
Why?
because we're looking at the first of S.
Yes.
Right.
So we only look at rules where S is on the left-hand side.
Okay.
Perfect.
Got it.
Now what?
Now we are going to step through the rule, right? So we need to look at first of A.
Okay. Look at the first of A. So what do we do with the first of A?
We check. Yeah, see, this is where it starts to come to pieces to me. So I'm not sure what we do here. We check what first of A has, right? And then we add that back to S minus
So
epsilon.
before we do that, what does Rule 3 say?
Rule
Rules 1 and 2 are just about non-terminals and epsilon, right? We're trying to calculate first of S, so right now that doesn't come into play.
Right.
So what does Rule 3 basically say?
If the rule A,
We have some rule of the form A goes to,
a non-terminal and then alpha.
call it B alpha.
Yeah. If it's a production rule, then you add the first of B minus epsilon to A.
Cool.
Got it.
All right. So, this is Rule 3. So, is this rule in this form? If we have non-terminal goes to a symbol, I guess it's kind of confusing that this is B. It doesn't have
Right.
a
No, it
non-terminal.
just represents a non-terminal,
the
right?
leftmost symbol.
Okay.
Exactly.
And
Yes.
alpha represents a terminal, right?
Say that again?
Alpha represents a terminal?
Alpha represents a sequence of terminals or non-terminals.
Okay,
so
so it
any
could be
number,
any.
Got it.
0 or more.
Okay. Okay. So yeah, it is in that form then, because we have S and then A followed by B, C, D. In this case, would be alpha.
Cool.
Okay.
So BCD is alpha, A corresponds to B here.
Uh-huh.
So then what do we add to the first of S?
We're gonna add whatever A contains the first of A. The difference
Which
is
is
epsilon,
the
right?
empty
Which is
set.
nothing, right?
Right?
So we add
Subtract epsilon, which is still empty set.
okay.
And then we add that to S.
Okay.
Cool. Then what does Rule 4 say?
Rule 4. So
We
if
don't have to do the exact definition.
okay, yeah, no, this is why I'm confused though. Okay, so so if epsilon is in the first of B,
Yeah. Okay. Yeah. So off of here, if epsilon is in the first of B, then what?
then we're gonna check for. Shoot, I wish I understood this better. Sorry.
Oh, this is why you're here and why.
This is where it sort of falls apart for me. Like intuitively, I understand how to find all of these. Like I can look at it and say, okay, here's this, here's that. It's the algorithm that I'm getting confused
Cool.
on.
So why don't you, if you can, I'll try and write the rule from memory, but I'm probably gonna mess it up. So
Okay.
check it.
All right.
And so we have. So if we have a rule of the form A goes to B0 ... DI
Yeah.
BI plus 1. And I guess actually here we'll also do alpha because this just represents everything after b I plus 1.
Okay.
And it could be 0 or more, just like here. So
Right.
So if our rule is of this form, and, right, logical and, so if this is true, and epsilon exists in the first of B0,
yeah.
and epsilon exists in the first of B1, and ... and all the way epsilon exists in the first of BI, then, right, so this is if this, then what? What do we do?
Then you're gonna add first of b I plus 1 minus epsilon.
B, I plus 1. Right. Okay. Right?
Okay.
So what is this saying?
I think what it's saying is that you're finding the first character or the first non-terminal in that string of b's that is not epsilon, right? Or that's not empty.
Necessarily the first, and that's the tricky part. So the question is, does this apply here when I in this case is 0, so I plus 1 is here.
Okay.
So is there an epsilon in the first of B0, in this case A?
No, I mean it's empty. It's the empty
No,
set.
so this thing is no, this is false.
Okay.
Therefore, this does not apply.
Okay.
So you don't even use rule 4?
Right now, we don't. We're just on the very first step.
Right. All right. So
Very
rule
first
4 doesn't apply. So then we check rule 5 then.
Check rule 5.
Okay.
So it's in a very similar form. Right? So it says if we have a rule, A goes to B0 all the way up to BK. Right? So every single symbol in the right-hand side of the rule, terminal and non-terminal, if the rule's in this form, so is this rule in that form?
Yeah.
Yeah, that makes sense. And epsilon exists in the first of B0 and all the way up to epsilon exists in the first of BK.
Uh-huh.
Then what?
Then we're gonna add epsilon to first of A, right? We just push the epsilon up to the front.
Right? So this makes sense, right? Because if every single symbol in the right-hand side can go to epsilon, then there must exist some combination of rules where A also goes to epsilon.
Okay.
Yes.
How is 5 different from 4? They're the same thing. When you say A from B0 to BI plus 1, that's the same as A goes to B0 to BK.
K is the end of the string. That's the key. The end of the symbols. Alpha here means that we have other stuff after it that we don't care what it looks like or if it even exists. That's the key difference. But the other thing is they both can apply. And
Yeah,
that's,
it still to me seem like they can apply. I mean, 4,
Mhm.
the only reason we couldn't apply 4 is because there was no epsilons in any of them.
in B0, right?
Yes. Well, okay, so there's no epsilon.
There's no epsilon in B0, which means does it make sense to check if there's any epsilons in B1 or B2 or B3, right? This is always going to be, no matter what we put our I to, right? We control I here. We make I B0, we can make I B1, B2, 0, 1,
So
2, 3, 4.
if there's no epsilon in this case in A, we don't care 4 or 5. We just move on to the next.
Yeah,
Like
same
we
thing,
check
right?
the next row.
Exactly,
Okay.
because 5 has that same condition. If
Okay.
epsilon exists in first of B0, well, if there's no epsilon here, it fails here and fails here.
I see.
They're both done.
Okay. Okay.
So we got no information, except for the knowledge that we're gaining from doing this.
Okay.
Cool. Now we go to A. So we have 2 rules, right? We have to remember to look at each rule in isolation. So we first look at A goes to CD, apply all these rules. And then we're going to look at A goes to little a, big A, and then apply those
Okay.
rules.
Why did we go to A? I thought we were working on A, saying
Oh, sorry. So we've worked on S, right?
Okay.
We applied Rule 3, Rule 4, and Rule 5.
Okay.
We're done.
Okay.
There's nothing more. There's no other rules.
So
S
every
has
time
no
you
other
call
rules.
first of something, you're looking at these rules and you're going to apply them
Yes.
iteratively 1 through 5.
Yes, for every one of these steps,
Okay.
S, A, B, C, D, you're going to look, like algorithmically, you look up all the rules that have S on the left-hand side.
Okay.
And then you apply rules 3, 4, and 5 to get new elements in the S's first set.
Okay.
And when you've applied that for every rule where S is on the left-hand side, you're done.
Okay.
In our programming assignment, those are going to be divided, right? The ORs, like
Yes,
A goes to
these
CD.
will be literally
would be
different
2.
rules. And
Okay.
so the important thing here, this is just syntactic sugar. This is just shorthand.
Right.
When you see this, this means there's an additional rule that says A goes to little a, big A. There's absolutely no difference between this and me writing it without this and saying A goes to little a, big A. It's just more condensed.
Okay.
And so it's just something to be aware of. I think on the exams we never use the bar because I want it to be very explicit. But when we write it like this and for homeworks, it's a lot easier to think about it like this.
Okay.
Especially because the bar has very similar things with regular expression bar, right? Cool. Okay, so let's look at this rule. A goes to CD. So, which rule do I apply first?
It's going to be 3, right?
Rule 3. So what do I do then?
You're going to add first of, in this case, first of C,
First of C, which is what?
the empty set.
The empty set. Cool. Minus epsilon.
Minus epsilon to the first of A.
To the first of A. Cool. Which is nothing. It doesn't
Right,
change.
right.
Now, does 4 apply?
No, 4 and 5 shouldn't apply because there's no epsilon in C. Okay,
So we
great.
stop. We're done there.
Okay.
But we can't finish. We have to go to the second rule.
Okay.
So then, which rule do I apply first?
In this case, you're going to apply rule 1, right? Because you have, so now A,
Well, we first want to apply rule 3.
oh, okay, no,
Right?
we're
Because
going to apply rule
calculating
3.
First of A.
Right, so first
Rule
of
3
A.
says take the first symbol on the left-hand side.
Okay. The first symbol on the left-hand side is a terminal.
Is
we
a
know
little
by
a.
rule
Exactly.
1
and
that
then
if
we
it's
say,
a terminal,
what's the first of little a?
little
the
a.
second containing A. We subtract epsilon from that. It's still the second containing A. Then we add that to the first of big A.
Got it.
This is great because you don't have to special case the terminals versus non-terminals when you're calculating rules 3, 4, and 5 when you're
Okay.
calculating first sets.
So you're saying that this isn't, so rule 3 technically isn't a non-terminal, it's just the first symbol.
Yes.
Okay.
Simple.
Okay.
I didn't know that.
So, okay, great. So now we're doing.
So we've added A to here.
Yeah.
Okay. Now we also have to ask, does rule 4 apply?
I don't see an epsilon in the set containing little a, right? So no.
Right. Exactly.
Okay.
Yeah, so you'd say, is there an epsilon in this first symbol here? No.
Okay.
Right? So rule 4 can't apply and rule 5 can't apply.
Got it.
We're done here. We've done all the rules with A.
Okay.
Now this is our current first set of A. And we're programming this, we would probably make a note that, hey, we changed the first set of A, which means when we get through, we got to do it again.
Okay.
Right? That's another thing you need to think about. Is
So
how do I
you-
tell when I'm done?
So you iterate. Okay. So you go first of S, first of A, first of B, first of C, first of D, and if any changes were made,
Do it again.
you run through that again. Okay.
And then if you run through it, you make no changes, you're done. Those are your first sets.
Got it. Okay.
All right, first of B.
Okay.
Which
so
rule do we apply?
first of B is going to be rule 3.
Yep, rule
Right.
3. So the
And
first of little b minus epsilon is the
is
second
little
containing
b.
little b.
Right.
Add
So
that
add
to the
that
first
to
of B.
first of B. Okay.
Now we get to C.
Okay.
So C, we take this rule first.
Yep.
So we do the same thing we did up here. Apply rule 3.
Rule 3.
Little
Yep.
c minus epsilon to the first of C.
Little c.
So we get little c. And then we say, does rule 4 or 5 apply?
No.
Nope. Can't move on. Great. Then we look at this rule.
Okay.
Right? Rule 3 still applies. Right? We have a symbol here.
Right.
So we take the first of that symbol, which is the second containing epsilon, by rule 2. And then we subtract epsilon from that, which
Okay.
gives us the empty set.
Right.
So we add the empty set
To C, which
to
is
C, which doesn't change it.
Okay. Now we're looking at
Now
4.
we say, does rule 4 apply?
Okay. So yes, it does because there's epsilon in rule 4.
Mhm.
Or I'm sorry, in C goes to epsilon. In this case, epsilon is B0.
Look at this one. Epsilon is B0.
Okay, so epsilon is contained within first of B0. Hang on. Yeah, because rule 2 says that first of epsilon is the set containing epsilon, right?
We'll get there in a second. Yes.
Okay.
I was gonna say so. In this case, why wouldn't it be rule 5 over rule 4?
They all apply.
Okay.
They all apply. We have to check each of them in turn.
Okay.
So there's no over. They're all going to apply, and that's why we do the add here, because they're all constantly applying, basically.
Okay.
Why keep starting with rule 3 and not 1?
Because we are talking about here, we're trying to calculate the first set of non-terminals. So it doesn't make sense to check rules 1 and 2, because 1 and 2 just say what's the first set of a terminal, and rule 2 says what's the first set of epsilon. Right?
Okay.
So we don't care about these when we're doing that here, right? When we're starting, so we always start with 3, but that leads us to using rules 1 and 2. Okay, let's think about this. So we have our B0, right? So I is 0 in this case.
Right.
So is there an epsilon in the first of B0?
Yes.
Yes. Then what does this rule say that we should do?
Then we add the first of B I plus 1, which is the empty set, right?
What's I plus 1 here?
There is no I plus 1.
Exactly.
Right.
So can this rule apply if there's no I plus 1?
No, I guess
Right.
not.
So the rule, so part of it's another thing that's implicit
Okay.
in this rule that we have all the way up to I and I plus 1.
Gotcha.
So if we're saying if it's in this form, right? Here we're saying B I is 0. That
Okay.
means there has to be a B1.
I see.
This can be 0 or more.
So this is protecting against the case such that you have like epsilon and then a terminal like later on in that.
Exactly. Yeah.
Wow.
So we'll see where this applies.
Okay.
Yeah, and I totally understand it, and don't be upset that you're confused, because I understand it's not an explicit
Yeah.
condition in here.
All right.
And so I get it, and I've struggled with, do I change the way I present these rules to be a little bit more
I see.
straightforward, or do I keep them more towards their like mathematical formalism roots? And so I kind of like that you have to learn this, and that you're translating this into code basically for Project 3.
No, I like it. No, it's good. It's good.
So it's nice and concise, but there are implicit things in here. So
Okay.
okay, rule 4 doesn't apply. Then we ask, does
Rule 5 is going to apply because the last set in that series of
Yeah. So what's the K here?
The K is going to be epsilon.
What number is K? Sorry.
Oh, 0?
0.
Yeah.
There's 0 symbols here. Okay.
Yeah.
One symbol.
One
One
symbol.
symbol in here. Right. So K is going to be 0. So
Okay.
A goes to B0. Right. Consistent here. And does epsilon exist in first of B0?
Yes.
Yes. So then what do we do?
We add epsilon to first of A, which is first of C in this algorithm. Or in this. Yeah. Wow. Okay.
And so this is the cool thing, is just like in this case, right, we didn't have to special case, oh, if B goes to a terminal on this side, then you do this. This falls out exactly the same way we did the other ones by just applying rule 3. And as long as we know the first set of a terminal is the set containing that terminal, we get this, right? Just applying this rule, this happens. The same as with this epsilon. As long as we know that the first set of epsilon is the set containing epsilon, then when we apply rule 5, it happens.
Yeah.
Even though here we're subtracting out epsilon by applying
Gotcha.
rule 3.
So what we're doing is we're trying to get all non-terminals that are not epsilon into the first of B, right? Like rule 3, it says like, okay,
Get
if
the
that's
first
a,
one.
yeah, get the first one.
You always get the first one,
Right.
no matter what. That's why there's no qualifiers.
Right.
You always get the first one minus epsilon.
Okay.
The fourth one says, can I move on to the next one?
Right.
Right? I've done I. In this case, I've done the first one. Can I move on and add the next one?
Okay.
And then if so, you check, okay, I've done the second one. Can I add the third one? Because this rule keeps applying.
Right.
That's the key, is we don't have any condition on I plus 1.
We choose what
Right,
I
we
is,
choose
right?
I, and we want to choose every single I. We want to start with I0 to add I to B1. We want to then check I1 to add B2.
Okay.
And then check B2 to add I3. And then this says if we went all the way through, and there's epsilons in all those first sets, then we add epsilon.
Yeah, epsilon. Okay.
So let's look at D.
Okay.
So here I have,
It's going to be rule 3,
Rule
right?
3?
Yeah.
Which is
And
going to add what?
the first of little d,
First
which
of little d
minus
minus epsilon, which is little d. Cool. Then does rule 4 apply?
No.
Rule 5 apply?
No.
Cool. Alright, then here, we do the same thing we did before. Add 3 minus epsilon is nothing.
Right.
Check rule 4, doesn't
Right.
apply, then add rule 5 to add epsilon.
Okay.
Now, it's important to think like this. I totally understand if when you're doing this, you simplify this and just say epsilon goes into the first of d because of this rule, right? But the important thing is understanding the mechanical calculations that fall out from these rules, because that is how you code it.
Right. Oh, okay. Okay.
And then we say, did we change? So we've gone through all the non-terminals. Do we change it?
Yeah, we did.
Yeah. So we got to do it again.
Okay.
Cool. Okay. So then we start here with S. So we apply rule 3. So what do we do here?
So it's going to be add first of b, which is first of a, right?
Add first of A,
Which is a,
which is just
which
A,
is a set containing a. The difference
minus epsilon.
minus epsilon. So the set containing a goes there. Okay.
Yep. And then does rule 4 apply?
No.
And so rule 5 doesn't apply? So we're done.
Okay, I see. And then we can just move them all as they go up, right? And then
Yep. And then now we do, let's do A again, and then I think I probably need to balance.
Okay, yeah.
So A, so let's do A, so we'll do this, let's go with this rule first.
Okay.
Right? So A, rule 3
It's
applies,
going to be first of c minus epsilon, so we're going to put c in there.
right? So we add C, and so you can do it 2 ways.
Okay.
This A came from here.
Mhm.
So you can look in the future a little bit and say, when I do apply rule 3 here, I'll get this A again.
Okay.
So you can either start fresh every time you do it,
Okay.
or you can copy over what you had before.
Okay.
Either
And
way
what would
works.
you recommend for the project? Start fresh?
No, I'd copy new ones in. I think the way I did it was like, you first initialize all the sets, and then I think before I calculated, I made copies of each of these sets for all my non-terminals, added to these, and then compared them at the end to see if any of them were different. But you could do it differently. You could set a flag if you change something, or
Okay.
it all depends on how you want to do it.
Okay.
Okay. So we added that, and then we say, does rule 4 apply?
For c, no. Yes.
So the
Yes,
question
it does, because first of c does contain epsilon.
Right, so I in this case is 0.
Okay.
So we say, does epsilon exist in the first of C?
Yes,
Yes.
it does.
Then what do we do?
Add first of b plus 1 minus epsilon.
So B of I plus 1 is D?
Yeah.
And so,
So-
we add
d, okay,
D.
minus epsilon, so,
Exactly, so we got to make sure we just add D.
right.
And then we say, does
Wait, why didn't we add c already?
Because I didn't write it.
Oh, okay.
I think I got off on the tangent about which one to do first. Okay.
Alright.
Then we say, does rule 4 apply again?
Yeah, it does. Because the first of b now, with I being d,
Right, so
Right.
I is then, would be 1 in this case. We have B0, B1.
Uh-huh.
So what do I add to the first of A?
Nothing, right?
Why?
Because you're subtracting epsilon from that. Right?
From
So
what?
from
Subtracting
d,
epsilon
yeah,
from
from
what?
first of d. So
I
first,
already added the first of D, right? So I
Yeah.
applied this once when I was 0.
okay,
So I think this kind of means for all from I0 to the end of the string,
Okay.
in some sense, right? So this one said when I was 0, we added B I plus 1,
okay,
right, which was 1.
okay,
We added first of D minus epsilon, which is how we got this D.
okay,
Cool. So I checked this one. Rule 3 says I always do this. Rule 4 says I can move on to the next one if there's an epsilon in this first set.
okay, gotcha.
Cool. So now the question is, does Rule 4 apply again?
Yes.
So what do I add? What's my B of I plus 1?
Empty, right?
Doesn't exist.
Doesn't
right?
exist, yeah, because the I plus 1 is there's nothing there. There's nothing after d, there's nothing that follows
Right.
d.
So 4 doesn't apply.
Okay, so 4 does, okay.
Yeah. Sorry, that's what I'm getting.
Alright,
So,
no, that's good, Okay, cool.
So 4 does not apply.
Right.
We can't, because the problem is it's not in this form, right? We don't have A goes to B0, B1, B1, B2, right? It is not in this form because we already checked the first here, so we went here. But the problem is it's not in this form. There's nothing after to add it.
Right.
So that does not apply. But now the question is, does Rule 5 apply?
Rule 5 does apply. My question, though, is B0 still C? Are we looking at
Yes.
B0? Okay, so we start with C. Okay, so we know that first of C does contain epsilon,
So
and first of BK is going to be D, like the last non-terminal in that sequence, also does contain epsilon.
Yep.
Therefore, we add epsilon to the first of A.
Yep.
Okay.
Cool.
Sick.
And then you'd walk through this, do it for D, C, and B, or B, C, and D. That's a weird type of dyslexic mixing. B, C, and D, and we change it, so we'd have to do it again. And you can already see that because we added the epsilon to A,
Yeah.
it's going to change how we do S now.
Right.
And so we have to keep that into consideration when we do this. But I think for now, I will stop
Oh,
this
that
here.
was awesome. Thank
I'll
you
let
so
you
much for
guys-
the help. I really appreciate it. Have a
Cool. You're
much
totally
better
not a
understanding.
plant to people watching online.